to Talking Maine with the bow tie boy. Got my tie, got my mask, got my Fred Flintstone vest on, and I have my special guest. And you are?
Richard Wilde. I'm the computer technology instructor at Foster Tech.
And before we start talking about our computers and all these weird things that these guys can do, I want to thank you again publicly for what you've done with scholarships for the kids. A lot of people don't know that you work at Ron's Market on Sundays, and what you get for income, you put into a scholarship fund that you give to kids for scholarships. And that's one of the things that a lot of people don't know, and I do, and I want to publicly thank you for that.
Well, thank you. It's a pleasure.
And you said you've been doing this for 15 years, is that correct? And how many kids have you touched with this?
Over 45.
Wow, that's fantastic. Well, thank you, because a lot of kids, that little extra dollar here or there makes a huge difference in them being successful or not. So thanks.
Yeah. And last year I started the Michael Bell Memorial Scholarship as well, so I actually giving out 4 scholarships every year.
Well, thank you. So, in the Michael Bell, you're doing it through the same, through Ron's Market?
Yep.
So Sunday's money that you take in for yourself, and you're going to divide that up?
Yeah, basically what I do is I do 4 $700 scholarships, and I do it by taking and sending them a check for $100 for the first 7 months of their academic career.
Wow, and that's a nice check when you're out there going to school to show up that you know that it's coming in. It helps you a lot, whether it's food or books or whatever. It's huge. That's the thank you. So, and I'll talk to the guy who owns Ron's Market. I think
John.
It's time for you to get a raise. Well, Richard, you do the program at Mount Blue. So tell us a little bit about that, because this year obviously was a little bit different, but you really have developed quite a group of kids that have gone out there with their robots and stuff like that. And we've actually come on at one time and brought your robot on. So tell us about the program.
Well, the program is a very intensive 350-hour program where we handle computer repair, programming, and also robotics. And this year has been a little bit different than most years because we're on a hybrid model, so I don't get to see all my students all the time. But in preparation for that, over the summer, I found some 3D printers online for $159.
Oh my goodness.
And so what I did is I purchased 10 of them, one for every student that I had in my class, and I sent them home with them.
Really? Wow.
And then I also sent home an Arduino kit with them as well. Arduino it's a small microprocessor which we use for programming different things. For example, R2 Bluetooth, he has 8 Arduino boards in him that all communicate with each other. And the kids ended up programming the drivetrain system for R2, and I mean, just using a little Arduino board. And so what I basically teach him is I teach him how to turn a motor in code. I teach him how to turn a servo in code. I teach him how to open up a relay in code. And I also teach him how to light up LEDs. Wow. And with those 4, you pretty much get everything that is encountered and also sensors as well. We also show him how to use sensors. As a matter of fact, for our next version of R2, we are working on a dome lift system that will actually bring out the lightsaber and bring out the light form scanner and everything else out of his dome.
Wow. Well, when that one's done, you'll have to come back on the show and show us how that works. That's pretty cool. Wow. Well, we'll get to R2 Bluetooth in a minute because we want to talk about him and so forth. So that's pretty. Now, did the kids how do they get involved in your class? They sign up for it? Do you have any prerequisites for them to be in it?
I like looking at students that have a strong math background because basically all we do is involves math. I mean, without mathematics, computers can't function. But they basically apply to my class. As a matter of fact, their applications are now open for all Foster Tech classes, and you do apply. There is an approval process. And the kids, I usually end up accepting pretty much anybody who wants to join, but I don't tell them that.
Yeah.
So what happens is I have a totally different educational experience than most teachers do, because I have kids that want to be there, want to learn the subject. If they didn't, they wouldn't have applied, they wouldn't have gone through the process in order to get into the class. And so we get to do a lot of really cool, fun things.
That's right. I forget, you know, in foster tech is such that you do apply. I'm applying because I want to be in that hands-on classroom and learn about this, and that's really important. And it's really important that more kids do that, because these are technical, hands-on experiences that they can truly turn into a job when they walk out the door, or go on into the next level, whether it's community college or technical school or something like that, that they can take to the next level with that. Do they end up with certificates when they come out of your?
If they pass the PC Pro certification test or the A+ certification test, they will get a nationally recognized certification. We also give them a certificate of completion showing that they have completed 350 hours of instruction in computer technology.
So they come on Tuesday and Thursday for your class, or?
I have my Monday group comes, I get half the class comes on Monday and the other half comes on Wednesday, and then Friday they're both remote. Tuesday's class and Thursday's class, I get half, and then
Friday.
It rotates every week.
Every
so
week.
It's a blue gold day
I
schedule.
gotcha.
So every other day.
And the class is 4 hours in the afternoon or 4 hours in the morning?
4 hours in the morning, you know,
4 hours.
which is another reason why the application process is essential, because first of all, you've got to like the teacher, and the teacher has to like the students, because you're going to be putting in a lot of time together.
Yeah.
So.
And you got to have the flexibility in your schedule, your regular academic schedule, to make sure that you can do that. And foster tech, if I remember correctly, takes from a region. It's not just from SAD9. So you could have Jay, you could have Rangeley, you could have Wilton. So you have SAD9, but you have the other sending schools that could come to be part of it.
Yeah.
Wow, it's cool.
So we have a lot of diverse students and a diverse population there.
Now, some of your kids, what have they gone on to do?
Well, actually, probably the one that I can point to locally is Josh Mishu of Exponet.
Yeah.
He was, as a matter of fact, he was one of my first Wilde Foundation scholarship recipients, and he's founded Exponet. I have other students that are still in the field, and then I have some that have chosen a different route, and that's okay as well.
Yeah. But Josh, you're right. Josh and Jeff Chasson have created quite a little business together. They're in the brewing business now.
Yes.
So he's moved into an enlightened business, and he's done a great job with what he's done out there. So this group was your robotics team too, correct?
No,
Oh, yeah, that was extra.
actually that's sort of strange, because I think this is the first year that I've actually had a student in my class be on the robotics team.
Oh, beyond the robotics team.
Yeah, most of the robotics team are a totally different group of students that come in that haven't taken my class,
wow.
because the robotics team's open to freshmen through seniors. And so, and we build big robots. We build 120-pound robots that do all kinds of fun things, like throw balls and drive over obstacles.
And we had one of those on the show a couple of years ago when you guys had won one of the contests that were out there.
Yeah.
So the robotics team right now is not participating because school's not in place.
We are. As a
you
matter
are?
of fact, I have been, the last few weeks, I have been working pretty close to 12 hours a day, because as soon as school gets over, we start our robotics.
Oh, no kidding.
So right now we're getting ready to compete at home. Basically, they have several tasks that our robot has to be able to do, and we film it right there at home.
Oh, so now the kids come into school to work on the robotics team too? So they do come in and they work on it. So then you're going to actually have certain things you have to do, and that you'll film that, send it into the judges, and then that'll determine the next step for you guys. Cool.
And we're actually, one of them is we have to do a small video describing our robot. And our robot's name is Juggernaut, which comes from Star Wars. You may have noticed a slight theme.
Yeah, a little bit of
developing.
theme here, yeah.
So we're actually considering doing our interview in a Star Wars theme and have Princess Leia and Luke Skywalker and Chewbacca.
Oh, good. I'll dress up as Chewbacca if you want.
Oh, that'd be awesome.
I got it. I do have a Bigfoot costume.
Oh, I've been looking for one.
I have one.
Yeah.
Oh, I got it. You have to remind me when we finish, and I'll dig it out for you. But
because I've been looking for one.
Bigfoot that would be close enough to Chewbacca.
Yeah.
I also have a gorilla one and an abominable snowman one, if you want to use those too.
I'm not so sure about the gorilla one in Star Wars, but we could definitely use the
Okay, good. We'll talk
Bigfoot.
after. I'll have to find it. So now tell me about some of the things that we have here today.
Well, this first one is actually a 3D printed robot, which we built 4 years ago. But we could never take it out of the classroom because it always had to be attached to a computer. And this year, and I'm going to give you that to solve so that you can show
Solve,
that
forget it.
Yeah. And we could never take it out of the classroom. Well, this year's students, what they did is they put Windows Internet of Things on a Raspberry Pi. Now, a Raspberry Pi is a small $32 computer. It has RAM, it has a processor, it has USB ports, video, HDMI output. It can connect to Wi-Fi, $32. And we set it up with a touch screen right here on front. And so now we can make Robbie portable. So.
All right, so I'm mixing this guy up, the old Rubik's Cube, so that there's no foul play here for Robbie. I'm going to give it back to Richard.
All we have to do, and this is a great child pleaser. We used it at Spruce Mountain a couple of weeks ago. And all we have to do is say, Robbie, solve. And Robbie should start solving the cube.
So what's Robbie doing right now?
Right now, Robbie is taking pictures. He's taking 12 pictures of the cube, 2 pictures of each side, one with the side ones pulled out and one with the top ones pulled out. When it gets done, it will have a picture of all 6 sides, and it knows exactly where every single face is. And then it runs an algorithm, and it will go ahead and solve the cube. And the kids absolutely love it when we take it to different displays and festivals. As a matter of fact, they like it so much that R2 Bluetooth has been getting jealous lately because he's getting more attention.
Robbie is.
Yeah.
So the pictures, I think, are showing up on the screen right now.
Right here on the screen, and then in just a second, it will start solving it. And so now it's in the process of solving. And if you look down here on the screen, it says that it's 31 moves. So you really mixed that cube up quite well.
Oh, good. I did go.
But this is a beautiful example of how we take something from the internet, because this is a design that was on Thingiverse, and we try to tweak it and make it a little bit better. You know, the same thing. We did the exact same thing with our 3D printers. When we get to the 3D printer, and I'll show you, but basically we take things and we try to improve them and try to think of ways to do different things. For example, in R2's dome, which we're working on right now, we have a Lifeform scanner that turns around. But in order for it to come back down inside the dome, it has to be perfectly positioned in order to come down. So I proposed that to the kids as to how we should do it. And finally, what we ended up with is by putting a magnet on the rotating part, we hooked up a Hall effect sensor. Now, a Hall effect sensor sensors the presence of a magnetic field. And it will send a signal to the processor that, oh, we've just hit a magnetic field. So when we want it to stop, we just hit the button, and as soon as it detects that magnetic field, the motor stops and it comes down perfect position.
Wow. Wow.
You know, now that wasn't included on the designs on the internet that we used, but it was just to make it a little bit better. And so that's a lot of what we do. I try to show them how to solve problems. To me, that's the secret. There you go, right there. Fully solved cube.
There we go. There's the white, there's the orange, there's the yellow, there's the blue, and he did it in 31 moves. How does he know how to do this?
Well, I would love to be able to take credit for that, but unfortunately, the person that needs to get the credit is O.T. Vinta, who actually came up with the code for that.
No kidding.
We basically, all we did is put it together, did a little bit of programming, and interfaced it with the Raspberry Pi.
Cool.
Okay, as far as the actual coding of the program, oh yeah, that's way beyond my capabilities.
So the pieces that are here, Richard, did you order them to put into this printer?
This is all 3D printed.
It's all 3D printing.
Yeah, it's all 3D printing. I have, I think, 8 servos, one that moves them in and out, one that rotates them on each arm, and then we have a servo board over here that controls the 8 servos, and I have a camera that runs everything.
Wow.
But we did all the wiring. We had to 3D print all the parts, make the adjustments, you know, so that it has the right amount of pressure on the cube. So I mean, it's quite a little task, but it was so satisfying when we got done.
So
with
you
it.
actually made these parts for the yourselves? Wow.
Yeah, 3D printed them.
Wow. All right. So tell me about R2 Bluetooth.
Well, R2 Bluetooth is about 3 years old, and he is the first 3D printed droid in the state of Maine.
No kidding.
Okay, we built him as a can we do it type project. And when we got done with it, we said, all right, great, we have a droid. Now what do we do with it? So we ended up donating it to the robotics team because my class built it. And so we donated it to the robotics team, and he has been a huge success. He went to week 0. You can see little stickers on him all over the place from all of his different competitions that he's been to. For a 3-year-old robot that is put together with solvent glue, it's just amazing. One of these days, I'm going to take him out, and he's just going to fall apart. I know it's going to happen, and that's why we're building the second version of it that's going to be better, stronger.
So I was actually going to ask this before we started, but I think you've answered the questions. All the things you see there, all his rounded dome and so forth, you printed on a 3D printer.
3D printer.
So you guys programmed, figured out what you want him to look like.
Again, you're giving me way too much credit.
Oh, but still, somebody
What
had to
we
do it.
did is, this is Michael Baddeley's design on the internet. He's from Liverpool, England, and he's this is famous on the internet.
But you still had to take that algorithm that he put together. You guys had to program it into your printer. Mm-hmm. You had to print it, and then you had to put it together.
And had to put it together.
So how big of pieces were they?
The biggest piece that we have on here is actually this dome section right here. That's the biggest single print that we have. And it runs from the top straight down, and it just fit in the bed of my printer.
Wow. And what is the material that you use to print that?
Well, R2 has actually got quite a few different materials in him. Most of his shell and everything else is PLA, which is polylactic acid. It's a biodegradable plastic. So if this ever went into a landfill in 10 years, he'd be nothing. As a matter of fact, you can see the effects of the sun on his upper ones from Rangeley 2 years ago, because it actually warped a few panels. He also has, his drive belts are 3D printed.
Huh, wow.
And they're printed with a material called TPU, which is a very flexible material. His wheels are printed in nylon, and we have certain holders for components inside that were printed using ABS. So we have 4 different materials in there in R2 altogether.
Wow. How long did it take you to put him together?
It took 2 months of printing on 5 printers to print him. Now, you also got to remember that you don't always get a great part every single time you 3D print. As a matter of fact, remember I said this was the largest panel? Well, this panel, I got it almost to the top, the first print, and then we lost power.
Oh, jeez.
It took me 7 more attempts to get it fully printed.
Oh, wow.
So, you know, there are some things, you know, and the more you attempt to print in one shot, the more you have a chance of having to wipe out all of those parts and start over again on those, you know. So, I mean, but we did it. We took it and put it all together. The dome is a stock dome. It comes from astromex.com. We use Curious Mark's boards and his setup for all the blinking lights and everything else.
Okay, yeah.
But the body is what I really I like, because there was nothing on the internet about how to animate the body.
Ah.
So what the kids had to do is we had to actually develop the code that runs everything, and he actually does drive forward, and these doors open up and the arms open up, and he's quite animated in his when everything's working correctly. And so they had to write all of that code, and then they had to tie into the code that was written up here, which to me is a real life example. You know, you've already got some code that's written, but
Now
you
you
want
have
it
to
to do a
do-
different purpose. So now you have to learn how to communicate with the other code.
Now, Richard, you also brought a printer, and
Yep.
maybe we want to wheel that in here, and we can get Andre to help us do that. Is this the kind of printer that would be printed on?
Actually, everything on this was actually printed on R2, was printed on this style printer. But this particular printer is about to be donated to the science lab at Mount Blue High School. I saved it out so I could bring it in today on the show, and this is a beautiful printer. We've printed some wind blades on it, and it just prints nice. And this printer was designed by my class about 2 years ago. And what we did is everything that you see above the aluminum here, most of those were just downloaded from the internet and printed. We did print the supports for the spool holder. We also made the Z-axis support right down here, designed that, and everything below this metal we did design.
Wow.
And so the purpose was to hide all of the electronics,
Yeah.
and get them out of the way and give a nice clean interface so that teachers could use it. And so we designed all of the, excuse me, here, we designed all of these panels in here, and if I was to pull one of them out, you'd see
all
that
the
the
electronics,
motherboard
yeah.
and everything else have their own special spots to land in. And this printer is one of 8 of them that the robotics team funded and donated to the science labs up at the high school.
Is this similar to what the kids have at home?
No.
They have something smaller.
They have something smaller, and it's a cantilever design, so it's a very small printer.
Years ago, I got to go to Oak Ridge to see one of their biggest 3D printers, and they told me the story of working with Peterbilt on some engine parts that kept failing. So they actually redesigned the engine part for them so that it wouldn't fail. I saw the biggest Mustang printed. They got challenged to print something like in 2 weeks, so they printed a Mustang car to put at the car show. This printer was as big as this room. It was huge. You would have loved it. I mean, I kind of followed what the guys were telling me about. I was really impressed. So we're running out of time, but real quick, can you tell me how I send an image to it so it knows what to print?
Yeah, actually, everything's stored on an SD card.
Oh, cool.
This uses G-code. G-code is used by CNC routers. It's used by, it's basically that it has a certain code that tells the machine how to go X, Y, and Z. I mean, when I first saw these, I was so upset with myself. We've had plotters since the 1980s.
Yep.
All they did was add a movable bed to it.
Oh, no kidding. So they can move it back and forth when you're laying the line down. Wow, this is fantastic. Cool.
But it's really great technology. I've been doing it since 2013. Wow. And I believe I also had the first 3D printer in Franklin County.
Wow, yeah, that's fantastic. Wow. I mean, to me, the technology's changed so much. For an old geezer like me, I have enough trouble turning my computer on and keeping it from dying than to try to manage all these different things, from putting the Rubik's Cube back together to R2 Blue 2 over there to the 3D printer. This is phenomenal. So, Richard, we'll schedule on a future show, maybe bring 1 or 2 of your students in, and we can do like we did before on the robotics team?
Absolutely.
Okay, so we'll look to do that maybe in April, because they can come in and we can alternate coming in and talking with them about what they've done, and then set up a little demonstration. That would be phenomenal.
Our robot that we have this year is really phenomenal. Cool. I mean, we went to, that first year that I came in here, that was a very mediocre robot. That we had a great drive team, but we had a very mediocre robot. This year's robot has got vision processing. It has a turret that tracks the target.
Oh, cool.
And it has a great accuracy. It's incredible.
So that's what we'll do. We'll have you come back on again and have let the kids tell their story about what they've got here. That'd be great. Richard, I want to thank you. I thank you what you've done for the scholarship program. Thank you for this outstanding demonstration. And yes, you are smarter than me. Richard, thanks for coming on. We'll see you next time. Thanks, everybody, for tuning in. Fascinating show today. Absolutely fascinating. Thank you. And we're working on getting that Wookiee uniform for you.
Yep.
We'll see you next time. Bye-bye.